All right, so we're talking about Lostromos. So who am I? I'm Nicole Hubbard. I'm the creator of Lostromos, and I'm an architect at WP Engine, focused on moving all of our workloads for our customers into containers running on Kubernetes. So WP Engine, we are a WordPress digital experience platform. So what that really means is we host WordPress for our customers and manage the entire aspect of that ecosystem around integrations with other things inside of WordPress and making that as painless as possible for our customers. So we manage over 300,000 WordPress installations for our customers, and we're moving those into Kubernetes. So we started with an infrastructure that looks something like this. We have a VM that's running Nginx, has a caching layer, PHP processing, storage, and MySQL. And we have 6,000 of these. That doesn't scale. So containers, Docker, Kubernetes, these are all the cool buzzwords these days, and that's how you scale, right? So we started down the path of figuring out, how do we move this into containers? So where do we start? So the first thing we came up with in our process of our evolution was to move the PHP processing, the most compute-intensive part, off of the virtual machine and into Kubernetes. This then allows us. So we looked at a lot of things to do this. Nothing would work out of the box, so we had to build our own custom PHP application server. It's written in Golang, and it runs PHP-FPM workers, and each worker is in its own individual namespace gel. And we just in time mount the site content for the WordPress install that's receiving the request into the worker so that the worker can process it, and then after that's complete, we clean up the worker and make it available for the next request. And so now we're able to deploy this worker application for every single VM, and it can process all of the installs that are served from that VM. So instead of having to manage 300,000 deployments into Kubernetes for every WordPress install, we only have 6,000. That number's 7,000 now, it keeps growing. And so for the purpose of this talk, when I talk about a storage domain, that also equals a VM today. We're looking long-term at better storage solutions than NFS over a VM, but you start with what you can. So we run the app server per storage domain, and so how do we deploy this? So all of the other internal apps that we built and run to maintain all of our customers' infrastructure run in Kubernetes now. They're moving that direction. They started a mixture of all sorts of things, and we deploy those with Helm. And so we wanted to take that same approach to deploying our 6,000 instances. So we have Jenkins, and it runs Helm, and we have 6,000 deploys for the same Helm chart. So we have one Helm chart with 6,000 deploys in Jenkins. That's 6,000 values files in Jenkins. Does anyone like Jenkins? Or do we all just deal with it because, it's what we have? That's what I thought. So this makes us very sad. We weren't going to go down this route trying to manage those files. And the only thing in those values files are information about the VM. Turns out our cloud providers know all of that information for us. So we built a little tool. It collects all that data, and it stores them in a custom resource in Kubernetes. So we then also built Lostromos, which runs in Kubernetes, and it reconciles our PHP application server deployments. And it uses Helm to do this. So how does this work? Kubernetes custom resources is the first part of that. Who here knows what Kubernetes custom resources are? Sweet, the majority of the room. So this is an example of a custom resource definition. So as you can see, it looks very similar to any other Kubernetes object. And in this case, we're defining a character in the namespace stable.nicolerene.io. And then we just define some information about how we access those. And then here we actually create a character. And in this case, we're creating thing 1 from Cat in the Hat by Dr. Seuss, just to keep it simple. So what Lostromos does is it watches these custom resources. And anytime a custom resource is created, a Helm release is created for that custom resource. Anytime the custom resource is updated, the Helm release is updated. And lastly, anytime it's deleted, the Helm release is purged. So it also runs a reconciliation loop. So you can specify any number of minutes that it waits, and every so often it will run an update for your deploy to ensure that nothing has gotten out of sync or been changed behind the scenes. And so demo time. So I'm also not brave enough to try to do this live, so I'm using a recorded demo. So let's see, here we go. How do I full screen? So I built a little simple demo app in Go. All it does is it listens on port 80, and it returns an environment variable called resource name, first appeared in the environment variable resource from, created by, resource by. So the same things we saw for thing one, we'll just print those out. And so we have a simple Helm chart here with the deployment for that. And so what we do, it's pretty simple. The important parts, though, are these environments. We have the values.resource.spec. So .resource gives us our actual custom resource from Kubernetes. Lostromos passes that in as values. And then we can access spec, and any field that's stored in the spec we can get. So we have name, from, and by. And now we have the Lostromos config. So we're going to tell it that the CRD we're going to watch, the group for that is stable.nicolerene.io. And then the name for the custom resource is characters. We give it our demo chart, and we tell it a namespace to deploy in, and we tell it how it can talk to a tiller. And then we do some logging stuff so that this is actually readable. Otherwise, it's structured logs, and that's painful. So now we will get all of the characters that exist already. So we have thing one and thing two. And we will go ahead and start Lostromos with its config file. And you can see here that we had two resources added, thing two and thing one. So as soon as it starts, it gets the list of everything and it deploys those. So those now have a Helm deployment for them. So if we jump down here, we can actually do a Helm ls, and we can see Lostromos thing one and Lostromos thing two are both created now. And then when we look inside the demo namespace and get the services that exist, we'll see that both the thing one and thing two instances exist for services, and we also have their deployments that were created. And those are running. So now we will just get the information for thing one so that we can hit it. And we can see thing one first appeared in Cat in the Hat, created by Dr. Seuss. So pretty simple. Now, if we go and we take a look, go faster video. So we're going to go ahead and create a new character called Nemo. And if we watch up here at the top, we'll be able to see at the top almost instantly, once we submit to create this, that Lostromos will receive that and go ahead and do the Helm deployment. Oh, yeah. So as you can see, almost as quickly as Kubernetes returned that the character was created, Lostromos already deployed it, and it exists inside of our namespace. And so now we can go ahead and get the service information again. And we can see that that one's running on port 3139. So we'll just tweak this. And we can see that Nemo first appeared in Finding Nemo, created by Pixar. So now we can come in here and we can actually edit thing 1. And so we've just got our standard thing, and we can see instead of thing 1, we'll make this thing A. And by, we will just switch to Nicole. And from, if I remember correctly, this is KubeCon demo because I'm reusing the video. And so as soon as that was completed and updated, we can see instantly up there at the top, Lostromos received that it was updated and redeployed that with Helm. And so if we come down here and we do a curl now on that one, we can see thing A first appeared in KubeCon, created by Nicole. And then we can also see that when we delete one, so we'll delete Nemo, we'll see up here at the top instantly again that Nemo was removed. And so this, for us specifically, allows us to manage our application deployments of the PHP instance. And so we have an operator we built that talks to Google and Amazon and gets the list of VMs and represents those for us in custom resources inside the cluster that's in the same region they're in. So we run about 12 clusters today in different regions at Google, and we're about to deploy 7 or 8 more at Amazon in different regions. And so that is able to only allow deployments for the VMs that are in the same region, so we don't waste resources or have to do anything manually. As soon as those VMs are created, that operator sees them and creates the custom resource for us. So Lostromos is open source. It's available on GitHub. So what's coming in the future for Lostromos, and where do we want to see that go? One of the big things is tillerless. Today, Lostromos actually talks directly to the tiller over the gRPC connection. So thanks to the CoreOS team, some of who are here today, we have a PR for Lostromos that removes the dependency on the tiller and instead imports the tiller package and does the work that the tiller does itself. That way, we're able to add owner references to everything that's created from your Helm chart, and we point that owner reference to the custom resource. So there's one little edge case where if Lostromos is offline and the custom resource is deleted, we never get the notification that it was removed. And since we tried really hard to keep Lostromos stateless, it doesn't know that something was removed while it was offline. So those things still stay deployed. With the owner references in Kubernetes, that allows Kubernetes to automatically clean those up for us. The other thing we want to add is currently you can only watch custom resources. We'd like the ability to watch anything. So whether that be a deployment that looks a certain way, anytime that's created, we also want to create something else, or anytime a service or an ingress or anything along those lines from within the cluster happens, we want to be able to act and do things there. And then additional deployment methods. Today we support Go templates and Helm. We want to add Case on it and anything else that anyone has ideas on. And then PRs are happily accepted. So any questions?
You, I think, addressed it already a little by saying you already support Go templates. I noticed just going through the README, it says supporting Helm and kubectl. Is that like more the better, or do you have a feeling that Helm is maybe a transitional thing? Because it seems like there's two templating approaches being coupled here. Like there's the CRD, which passes values, which you pull out, which you put into another templating engine, et cetera, et cetera. Where do you see that going?
So I don't really see that going anywhere. The value there is we're able to store the values that we need to use for the templates in the CRs. And then we're able to just apply the same template. So in our use case, we're applying the exact same chart, or even if we were using a Go template, it'd be the exact same template for every single thing we're deploying. The only thing that's different are those values that are stored in the CR. So we see those as two separate things. One as a way to store the state of what and the values we need for deployment, and the other for actually controlling what that deployment looks like.
Can you elaborate a little bit on what you mean by you can't watch Kubernetes objects?
So you can. Kubernetes supports it. Lostromos doesn't support it.
One more. So currently, do you use multiple namespaces? And if so, were you communicating with a separate tiller per namespace?
So that is up to how you want to deploy it. Currently, Lostromos only supports a single tiller. So if you wanted to, and at this time, you can only deploy from Lostromos into a single namespace. It's one of the options you pass in. Our recommendation is if you want multiple namespaces and multiple tillers, you would deploy a different one for each namespace. So for our use case, we also deploy the tiller as a sidecar, so that only thing that can access that is Lostromos. And then with the core OS change that's coming, we actually get to remove that completely for security purposes.
How do you manage rollbacks and roll forwards?
So currently, Lostromos itself does not handle that. As we do deployments, so for our pipeline, we've built an entire pipeline that will go and update the config map where we store the Helm chart for our internal deployed version of Lostromos. And then that will get updated as within a couple minutes. We usually see it within 30 seconds as Kubernetes updates that for us, since it's mounted as a volume. And then during the next reconciliation loop, Lostromos will push out the new template because it'll see it had changed. And so whenever we need to do a rollback of a version, we just update the template with the old version and push that out. And then for deployments, we've broken our Helm chart. So in those CRs, we're adding what phase of the deployment it is, whether it's canary or testing. So we have different ones, and we can arbitrarily define however many. And then our Helm chart knows how to look at those and correctly deploy the correct version, depending on what phase that VM is in.
Lateral pass here.
In one of the part of that you said, you mentioned that you basically have Lostromos being stateless. So now what I'm seeing is that you're deferring the stateful part of it to Kubernetes. So basically you're overloading all the states to etcd. Have you had any contact with the community to see if that's a good idea or not? Because I have heard some people saying, well, that's maybe not the best idea in the world to actually use Kubernetes as a stateful object to store your states. But then the CRD is really intriguing because we're trying to use it more or less the same thing, and I'm debating should we do it or not.
So we haven't had a lot of conversations around that specifically. So we do store some state there in the CRs. The other state, the more important state of what's been deployed, we defer to let Helm manage currently. As we move forward with the PR that we have open to remove the tiller, that state actually gets moved into the status field of the CR. So that might be something we want to evaluate whether or not that's a problem with etcd.
Oh, way over there. Sorry.
Have you considered using finalizers to solve the edge case you mentioned, that when CRDs get deleted, you don't get notified?
We have not. I've looked at them a little, but I haven't dug into them enough to see if they completely solve that edge case for us.
Okay. Yeah, I think it will solve the case. Yeah,
Okay.
thanks.
Anyone else? Awesome.